Hello, in this video we will introduce skewness and show how to calculate skewness in R. So skewness or skew is a statistic which is used to measure the asymmetry of the distribution of data. So usually we want to have an ideal data set which is symmetric, like a normal distribution data. But sometimes data is not symmetric and it can be has this shape or the other shape. So this is called positive skew because you can see this long tail on the right side. So which means the distribution of the data is many values alongside the higher part of the data. And this is negative skew. So the lower value of the data has longer tail of the distribution. And if we look at the mean or median, so in this example, the mean can be here, but the median maybe stay here. So in the positive skew, the mean value is less than the median value. And in negative skew, the mean value may be here, but the median may stay here, there. So the median value will be lower than the mean value in this shape. And how to calculate or the definition of the skew in mathematical form. So we will see these two parts. One is M3. This is the third moment of the value against its mean. So y is the data, right? So each value of the y minus its average, then take cubic, third power, then sigma summation, and divided by the sample size. So this is called third moment. And S3 is actually the standard deviation, S and take cubic. So we just write S square is the variance, take a square root, then take a cubic. So the skewness then is the division of these two parts. So we just show this a gamma 1 is M3 divided by S3. So if this value larger than 0, so indicate it has a positive skewness. And if the value is less than 0, it indicates negative skewness. And if the value is 0, they indicate no skewness or the data is symmetrical, right? And if you want to test because in the last page, there's not necessarily exactly the data has 0, even it is symmetrical because we have sample data, so you have some randomness. So we have to test, for example, hypothesis testing if the data has a skewness or not. So in this way, we can use the skewness, the value minus 0, then divided by its standard deviation. And its standard error equals, for the sample, standard error equals 6 divided by n sample size and take a square root. So in the previous page, the skewness divided by this item, then this statistic follows a t-distribution with n minus 2 degrees of freedom if the data or if the null hypothesis is true. The data comes from a symmetrical distribution. So we can calculate the p-value of this statistic under the null hypothesis. So we can reject it or not reject it. And then we will show how to implement the calculation of skewness using R. So there are usually 3 ways to calculate the statistic of skewness. The first is you can write your own function from the ground off. Then next is using E1071 package. They have ready-made functions for skewness, and similarly can use function from the moments package. So these two packages have to be installed first. So next we go to RStudio. We just load a data, set the working directory, and we read this data. Then we show this data information. There's a very easy data with only one column called values, and there are 30 observations. So this data frame has only one column, one variables called values, and there are 30 rows, 30 observations. So we just attach this data. So next we can be much little easier to not write the data set, just write the variables. Then we can write a function called skew. So this actually is M3, S3, then M3 divided by S3. So this is based on the definition of skewness, the third moment divided by the cubic of the standard error, right? So this function is done. So we can show the histogram of this data. You can see this data is actually a little longer tail on the right side. So maybe this is positive skewness. So we can calculate skew because this is the function we have written. Then skew values from this attached data set, this variable. So it is a 1.3189. It is positive. And if we want to test the hypothesis that data coming from asymmetrical data, so we can use skew value divided by the square root of sample size, so length values. So this is about 2.24. So we just Next, we can calculate the p-value. So you can use pt. 1 minus pt is the p-value on the right side of this value, because on the left side p is for the cumulative probability. So 1 minus this cumulative probability is the p-value in the t distribution. So this p-value is very small, lower than 1%. So it is highly significant. So we can be confident to say that the data not coming from a symmetrical distribution. So I'll say that we reject this null hypothesis that the data coming from symmetrical data, because this p-value is quite low, much lower than 0.05. And next way is to use E1071 package to calculate this skew value. So I have installed the package. So we just library E1071 to load this package. Then next you can just use the skewness function from this package. So skewness values. So we print this value about 1.3877. So little different because the different functions algorithm. Then the third way is to use the moments package. I have installed this package, so just a library moments to load this package. Then you can use the same function, but this time skewness comes from moments package. So we show this value 1.3877. So this is a very basic implementation of skewness calculation in R. Thanks for watching.